What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're back with another live coding stream where we try to build something cool, basically from scratch. It's sort of a long-term project we got going on here, so it's not like we're building something brand new from scratch every time, but we're working on something pretty much from scratch, low level, as much as can be whenever we're doing these streams, which I find to be a lot of fun, and we're going to do a little bit more of that today. So I'd like to say hello to some people who have arrived right on time. We have Mr. Bill, Alejandro, and Felipe. Thank you very much for being here, guys. I appreciate it. Let me see if I can get this backdrop to stop flopping around. Man, I'm so ready to get into a better streaming situation because this is just ridiculous. And also, one new thing today is that I'm also streaming on Twitch at the same time. Hi, Daigo. Twitch.tv/Flux Harmonic Live. If I go straight to the page... Flux Harmonic Live. Unfortunately, somebody took Flux Harmonic a long time ago, so I have to use Flux Harmonic Live. But if you prefer to use, make sure I'm not gonna hear myself. If you prefer to use Twitch, then you can use that instead. But we all have a good time here on YouTube, so whatever you prefer is fine. Hey, Gon. So let's see, today, the goal is to bring back the circles, basically to wire up the scripting language to the point where we can get our circles rendering again. And in the lead up to getting the stream ready, I was trying to do a little bit more refactoring to the code to make the parser use the new vector API that I created. And I'm sort of in the middle of that right now. So we're gonna have to start from that point and see if I can finish that work before we're gonna get to the actual meat of the topic today. But the main reason we need to do that is so that the looping that I need to do to process call expressions and pull all the keywords out, we need to have some of the logic that I built into vectors to do that effectively, especially whenever you have multiple expressions in the file. So we're gonna work on that first, and then we'll get into the other stuff. In the way of some updates, I am going to change the streaming schedule slightly. So it's been fun trying to do these streams twice a week, 3 hours each time, but it also takes up a decent amount of time on Tuesday and Thursday. So I'm going to cut both streams back by 1 hour each. So they're both going to be 2 hours. One 2 hour stream on Tuesday and one on Thursday as well. I'm just going to move the time up 1 hour. So we won't be starting at this time. We're going to be starting 1 hour from now, basically next week. And we'll see how that goes. Obviously, there's not as much of a chance to make as much progress in the streams, but maybe they'll be more digestible to people if, I'm not running for 3 hours and we're sitting here trying to dig through issues the whole time. So we'll see how that goes. I'm sort of just experimenting with how to make the streams and the channel more interesting and sustainable. So definitely I'd love to hear all of your feedback, those of you who are watching live and those who watch the recordings, since there are a few of you who do watch the recordings. So let me know what you think about how the streams have been going so far. And if you have any thoughts on how maybe I can make them a little bit more interesting or more engaging, or maybe if there's things that I'm spending time on that are more boring than other parts that maybe I can do behind the scenes instead of doing on the stream, because I want this to be cool. Like, the stuff that we work on should be cool projects and, nice outcomes. But 15 o'clock Zulu, is that UTC? Yeah. I think it's right now it's 2 p.m. UTC, I think, right? So there will be 3 p.m. the start time. Anyway, point being, really would be interested in feedback on what I could do to improve things, because I want it to be fun. And I've got some other ideas for things, how we might change things up a little bit as well. So we'll see how we do that over time. But for now, we were having fun writing some code. So we're going to continue to do that, at least for the foreseeable future. Mr. Bill says I could watch for hours. Well, I appreciate that, because sometimes I wonder if this is interesting at all, but I appreciate those of you who come back each stream. There's a few of you who are here right now that are here every time, and I really appreciate that. Once things start to get built up over time and we have more stuff, cool tools to work with, I think the streams will be a lot more fun. But at least for now, we're at the very, very early stages, so you all are having to come along with me on this journey of building things up from the very, very bottom. Let's see, anything else from that perspective? No. I think I might actually start doing short videos on this channel as well. not educational videos per se, but maybe videos just on sort of like, I had a thought about a video I could do for this channel, something about maybe like how to come up with project ideas. Like if you want to do creative projects specifically around coding, you know, how would you come up with project ideas, especially if you want to use them as a way to learn like a programming language or maybe a new platform you're trying to work with, etc. So that's something I'm thinking about making a video for on this channel, unlike what I do on System Crafters, which is more specifically about, you know, leveraging specific tools to achieve a particular result. So maybe we'll do some stuff like that too, because I want this channel to have its own kind of unique identity. All right, so today's task, we're not gonna spend any time just, you know, talking so much this stream. We're gonna get right into the work because there's quite a lot to do, it seems. So the things that we left off with last time are, well, let me start with one that is actually gonna need to happen. Finish porting, let's see, parser to vector library, or vector API, I guess you could say. Hopefully this works. I'm at a point now where, well, I'll tell you about it when we start looking at it. Then the next thing would be simplify finding keyword name value pairs in function calls. So the primary way we want to pass function parameters to, well, parameters of functions in the scripting language is by using keywords as, you know, to make the name of the parameter obvious whenever you're looking at the document. But to do that, you have to look for both the keyword and then the value that comes after the keyword. So I would like to try to figure out a pattern for making it easier to check for those. And it's not necessarily going to be straightforward. So we're going to have to experiment a little bit, but this is definitely a place where you guys can come in and suggest some ideas. We may skip that one if it ends up being a rat hole, but you know, something I would like to do because it's going to show up a lot when we're writing these functions that can translate between the scripting language and the C layer. Also, finish porting previous Guile interface code over to the new language. So last time we were able to get the show preview window command or function working so that we actually do show the SDL window from within the scripting language now. We started working on getting the circle function ported over, and that's when we started trying to read the keyword parameters and pull those pieces of information out. But now we still need to go and get like a scene creation working. Hey, Bill. And I think that was it. There was the other function, the render to file function we had started working on that sort of led us down this path to begin with, that we'll also get back to. But we will try to get that all working today so that we can start rendering those circles again, at least get back to where we were before. Now, after all this is done, or after we're all working with this again, I might take a break from talking about the scripting language and start moving on to some other more infrastructural work that is potentially more interesting in the short term. For instance, I would like to convert the code from using SDL2 to using GLFW and just working with OpenGL directly. And that's going to take a little bit of work, I think, to change the code because we were sort of making some assumptions based on SDL2 already, and I would like to get away from that. It also requires them, and I have to pull in specific libraries for things like loading images and some other things we might have been using from SDL2 already. So that's something we might start doing on the stream next week. And then once we build up some stuff in that area, we might go back to the scripting language, and I might have worked on some of it a little bit behind the scenes by then to put everything together and then really start working on the actual, you know, thumbnail rendering code that we have been trying to get to for a while now. So, excuse me. So I think that, you know, doing that conversion to GLFW, or at least talking to OpenGL directly and not having SDL2 be the mediating library, we should probably do it now rather than later because I'm going to become more and more dependent on SDL2, and I'd like to avoid that. So we will probably do that next week when we get done with this particular part of the work. Regardless of how much progress we make on this today, we will do that what I'm talking about, the GLFW part, next week for sure. All right. Excuse me. So that is it for what we're going to do today. Let me jump out of the presentation mode here so we can take some notes if we have to. And let's go on to looking at what I was doing for the conversion of the existing parser code. We're in script.c. Now, basically what this amounts to, and in fact, I don't know if I should show the diff. Let's see. the most important part would be in script.c, where we're introducing a parse vector instead of having this sort of void pointer to a memory block before. Mr. Bill asked, do you have any experience with OpenGL? Yeah, I've used OpenGL on and off for probably, how old am I now? Probably 20 years, I guess, on and off. Not full time, but I've got enough experience with it. There's things that I don't know though about some of the more advanced aspects of OpenGL, like shaders and the more higher performance rendering aspects. But that's some of the stuff I want to get into in this channel. So we will do some of that as we go. And let's see, I got rid of some of the helper functionality that I had for dealing with expression lists specifically. So a lot of this stuff is what I was needing before whenever I did not have a standardized implementation for the vector approach I was using. And I've basically simplified a lot of the code, but now I have to go and convert the rest of it to work with this new model. And I'll tell you a little bit more about that in a minute. And let's see, yeah, in the vector library, I added a little bit of extra stuff to it to help with some of what we're doing here. And we could talk about that too. And one other thing that I've added, which was something that probably will be needed, is this idea of the buffer usage size. So how much of the memory are we currently using with the current vector? And that's going to be helpful when we have basically sub-vectors, where you have a vector that contains a vector as an item, and you need to be able to skip over it. You have to know how big it is without having to actually iterate over it to figure out how big it is. So we're going to have this buffer usage to help us to jump over a nested vector. This is all getting really complicated, I think. It starts to make me think whether this vector approach that I'm using is actually worthwhile, or if it's a liability as far as potential bugs might be concerned. We're going to continue using it for a bit, but I have been considering the possibility of going back to a simpler, basically like a linked list model, where we do allocations dynamically and then link the nodes together so that you can traverse them sequentially. However, that does get us back into the sort of the memory fragmentation problem. It wouldn't happen at first. I think that the first few times you evaluate something in the process, you have fresh blocks of memory and things. I think malloc is typically going to allocate things sequentially as you ask for memory blocks. But as these blocks of memory that malloc has get used and certain things get freed, then malloc is going to try to find slots inside of the free space in those blocks. And then we're going to get new objects are going to be placed in various different places in the memory. And then we have issues with the CPU cache having cache misses when we're reading around in different spots of the memory for finding the next element of everything. Now, this may not matter that much in terms of performance when it comes to parsing the code and evaluating the code, because we're not going to be evaluating it every frame. We're only going to evaluate it whenever it's requested, at least for now. So it may be a moot point entirely, and I might just be barking up the wrong tree. But like I've been saying, some of this is just an exercise for me to learn how to do this stuff better. So that's why I have been considering doing it this way so far. Let me turn this music down just a little bit. I don't know how loud that sounds to you. So we're going to stick with this, even though it's getting more complicated. And if it ends up getting complicated enough where I think it's not worth it, then we'll switch to using something like a linked list or maybe some other data structure instead. All right. I think that's everything relevant for now on what I've done so far. And we'll get back into it by looking at the place where I left off earlier today, which is this function where we need to parse the list. So we're in the code to actually parse the tokens that might correspond to a list. And actually, this is not really a good name for this function. Maybe it should be something like parse tokens or something, because it actually handles different types aside from just lists. But what we see here is that we're still using some code that is relevant to the old model of calling flux script expression list push, which was sort of the custom implementation of vectors for this part of the parser. but I'm trying to get away from using that. And I'm skipping this part right now because this is the part that deals with sublists, and I'm not really ready to deal with that at the moment because we sort of need to understand how the conversion is going to look for the simpler types first, and then we can jump into the sub-vector situation. What I have done so far is convert the simpler token to expression conversions like symbols. So previously, what I would do is get a symbol pointer or a expression symbol pointer and assign it to the memory location where the cursor currently is. So we can basically take, so we're moving a cursor from the start location of the allocated memory all the way over to the places where new objects are being added. So at this point, we would say, you know, take a pointer to the current memory location where the cursor is in the vector, pretend that it's an expression symbol, and then just start populating information into it by setting the fields of that struct. So now we're taking a different approach entirely, where we're creating an instance of the struct in the stack, basically as part of the body of the function. We're populating it, and then we are pushing it onto the vector using flux vector push, which then just uses memcopy to copy that local variable, which we're referencing with an ampersand to get the location of that local variable. So we're referring to it, and we're using memcopy to copy it, basically so we can avoid having this function call cause a copy from, you know, passing the value of the struct to that function. So flux vector push is going to use memcopy. Let me go see if I can grab that function really quick. Vector.c push. So we basically just get the size of the item, and then we use memcopy to copy that item based on its size from the source location to where the cursor currently is in the vector. And then we just do the bookkeeping for saying, you know, where we are with the index of the cursor, you know, add another item to the length of the vector, etc. So this is simpler than what was there before, I think, but it does raise complications when you start dealing with the more complicated or the more elaborate expression types. Specifically, the one for expression value. Expression value, if you go look at that one, I think it's in flux internal, expr value. This one is a little bit funky because it has the expression header, which is basically just the kind of expression. But it also has value header here, and this is meant to actually be whatever actual real value type that the expression value corresponds to. We're only using value header here, which only contains what the kind is for the value, but we're sort of overriding it to contain more than that, like the actual struct size for whatever the value type is, which is a little bit shady. Probably not a good pattern, but this is what I'm doing so far, and it has been working, though it does cause problems with this new approach where I want to take a constructed instance of the struct and then copy the memory into the vector at the destination location. The reason why it's a problem is because of this way that I was populating that value field before. What I was basically doing is taking the memory location of that struct field and then pretending that it's whatever value type that I want and start writing stuff into it. And then I'll just do the math myself on the pointer whenever we need to move to the next object. So I could take into account the different size of what the value type would be. Now, I can't really play with things the same way that I was doing before. I mean, I sort of can, but I feel like it gets a little bit more murky. So we're going to take a look at this really quick and see if I can find a resolution for it. And then later we will maybe change course if it turns out to be a terrible, terrible idea. So let me grab a little sip of water here and we'll get moving. Okay. So what this code is currently doing is it's looking at the integer local variable, which is of type expression value, and it's grabbing this integer value struct field. And if you use the ampersand, you can basically get the memory location of where that struct is in memory. And then we're pretending that it's a value integer. So by default, well, actually, because this is a stack variable, this might be dangerous. And the reason why I say that is because if you have this memory allocated on the stack, you don't have really control over what comes after this expression value in the the stack local memory. I don't really know the right terminology for that. So if I start writing past the value, what the size of that field is supposed to be, I might be overwriting other things that are necessary. So that could be something that would cause a problem. So I might need to rethink how I'm going to approach this a little bit. And the thing I was thinking before is maybe if I have a way to insert something else after the object that I'm putting in, but I would be inserting something into the vector that is not actually the same type as what is already in the collection. So the vector that I'm using right now is a vector that has items that are sort of more or less derived from expression header. But then if I start inserting a value header into that vector, then all of the logic is broken, because now we have this new thing in there that has its own set of kinds, its own integers or enumeration that represents the kinds. And when I pass that into the function that can tell me what size something is in the vector, it's not gonna work anymore. So the first thing that comes to mind for how I should deal with this is that maybe I should not actually do this value conversion right here. Maybe the evaluator should take care of taking a specific expression integer and then turning that into a value at that point in time. That may be the only way to make this work correctly. And the reason why I did it this way to begin with is because I thought it would be like a little bit of an optimization. Like, okay, I know this is eventually going to be a value because it's a literal. It's like a string literal or an integer literal. So let's just go ahead and create the value, and then I can return that directly whenever I evaluate the expression for that value. But it seems like that's a liability now. So we may just go ahead and change that behavior entirely just to make this cleaner and simpler. So maybe that's what we'll go ahead and do. What I can do here is take this stuff that I've already put together. Well, let's copy it. I need to keep this to use it as well, but I'm gonna go down to the eval function, eval expression, let's say. So we have expression kind value. Maybe what I'll end up doing here is case expression kind integer, return. We're just gonna do this right now. Whoops, return null. We'll go back and fix that. Case expression kind string, return null. And then at some point in the future, we can decide to improve this. But for now, I think we need to just move forward in a more reasoned way. It looks like a switch statement is warranted already. Yeah, well, for this part, definitely. So let's see. Let me go back to expression kind. I'm gonna go delete this. Wait, why did it jump right there? All right, so we're gonna change this. We're gonna change this to integer, and we're gonna add expression kind string. All right, and then for the value type, we're gonna change this to expression integer. And it kind of feels like a, I don't know, like I'm converting a token for a string literal to an expression of a string literal, and it's basically a one-to-one conversion. But I don't know, it feels like it kind of necessary for now. It's simplistic in a way, but maybe it's better just to make things very explicit so that we don't run into trouble, because we've already seen trouble now as a result of this. Okay, so token integer. I'm just gonna grab this int number. Whoa, why did I jump to this file? Okay. Expression integer, we're gonna drop this in right here. And then expression string, we're just gonna rip off what's in token string. We will grab this part. And then we will make our expression string here. We'll get rid of this little bit. Expression string. And this probably should be something like expression integer literal. Oh, is the stream breaking? Let me just check the, okay, looks like I'm still connected. Let me know if the stream stopped for you. Okay, it seemed to buffer for a minute on my my display here. Okay, so I think those two are what we need for now. So I can go back into script.c and then jump up to where we were creating the values before. I think that was right about here. and I'll grab this part, jump down to expr integer. Whoops. Hold on. Expr kind integer. Okay. And for these, I think I can make these normal stack allocated structs. No buffering. Thanks, Mr. Bill. And let's just let's see. We don't need this anymore. Int value, header kind, value kind integer. And then instead of this, we'll grab expression integer. What is it? Expression? Yeah, expression kind number. And then, wait a minute, hold on. Yeah, so we need to convert value integer to also start using the vector type as well, which is going to be easier because I haven't really used that one very much yet. So we'll do that right after this. And we'll also convert this to use stack allocated structs. Let's do that. We'll change this to expression string, change this to expression string, and that should be good enough. Let me just leave a little to do here, fix this so that I don't forget it. And then this part goes away because we don't have that type anymore. And then back up in this area where I was before, things are a bit simpler now. I don't need expression value. I need expression integer. And then expression kind integer, I'm going to set here. And whoops. Is it token or expression? This part right here is definitely a token because I'm saying what the original value is for this. So let's go back and delete this part, and then we can fix this to just be integer dot number. Okay. Hey, Arnav. No, it's not the latest setup. I need to get that site updated. The latest stuff is in my Geeks home branch in my .files repo on GitHub. Okay, so token integer, token number. Let's fix this. And that should be enough. So now I can change this back to flux vector push in the case statement. I'll take a look. This is right. Yeah, at least this section right here is right. Maybe I need to go somewhere else. Oh, I think, is this what Felipe was talking about? Yeah, I probably should be using a switch in this area for sure. I don't know why I wasn't. I probably was just, coding at full speed and not really thinking too much. All right, so we're going to fix this to be integer. Come on. Sometimes the G key is not playing nice. And then we're going to fix this one also to make it be expression string. I don't know if this should be str. I don't know if string is a special name in C. Probably not. Okay, so don't need this part anymore. That part looks good. Now I'm going to go delete all this up to this point. And let's go delete this section. String dot. And then here we could take this part out. String dot. Is that right? String dot string. Oh, okay. And we can also use flux vector push for this part. All right, so now I think we're getting close. We just need to deal with the sub vector issue. Value kind string, that's wrong. This needs to be expression kind string. Okay, whoops. Setting integer, setting keyword, symbol, all right. So now this is the section we need to update, and this logic is a bit more complicated, but that's sort of why I added the extra, the buffer usage, I think is what I called it, to calculate how many bytes are currently being used for a vector without having to iterate over it. So let me take a little think on this one for a second. So we get into this, we're looking at an open parenthesis, and we know that we have a sub expression, basically a list that we need to deal with. The sub list, we're saying flux script expression list push. Now, this is where things get a little bit complicated, but I added something to try to help with this. So instead of trying to push something onto the list, what we can do is set up an expression list at the current location. So let me go take a look at that type. So exper list. Okay, so the way we have it structured is that we have, I've changed this so that we have the header as usual, but we also have a vector as the second member of this struct. And this is going to be useful because it will allow us to allocate a vector instance that we can then set some things in. So sub list, or maybe even sub vector, we can fix that later. And this is going to be stack allocated. And then we'll push it onto the list. Trying to think of the right order of things. I think pushing it is going to be the right way to go first. This list cursor we're not going to use right now. This init we don't need yet. So what I will do is set the kind sub list dot header dot kind to exper list kind. Okay. And then we need to set up the vector. And I need to set this up, well, let's think about that for a second. Yeah, that's going to be fine. We will init the vector. So flux vector init. Yep, that's the one we want. And for this, we're going to pass in sub list dot items, but we're going to use the ampersand to pass the pointer to that because we want to initialize that struct that's part of that parent struct, basically. And for the size function, we're going to use flux script exper size func. I think I have that defined up here. Or is it just, oh, exper size, all right. Do I have token size defined with that naming? Yeah, that's what it looks like. All right, so exper size func. Let's just change this to exper size. And that should initialize the vector. Okay. So flux vector init. Let's go take a look at what that does really quickly. Vector.c underscore init. Oops, underscore init, not unit. All right. So we set the start item location to 1 past the size of a vector type. We need to deal with this buffer size issue at some point because this flux vector init is basically meant for this case where you have a vector that's supposed to hang out in memory that already exists that hasn't been allocated by this vector API, which would happen if you were using flux vector create. So flux vector create basically allocates memory for the vector and then calls flux vector init. So flux vector init just allows you to skip the allocation step, which we need in this case because we already have a location in memory we want to write the vector contents to. So flux vector init is just going to put it in the right space to be used. And then we can use flux vector push to push this sublist onto the list cursor. And now we've basically got the vector set up. Let's see, why is that? Okay, yeah, I need to use and on that, or ampersand. Let's see, why is it also unhappy? Incompatible pointer types passing exper list. Oh, hold on now. The cursor is the first item. All right, cool. List cursor and then ampersand sub list, if I get my syntax right. Okay, that should be the right one. So now we've got the sublist subvector pushed into the parent vector, and now we need to make it possible to start adding these sub items to that sub vector, or the items to the sub vector. So what we need to do is establish a cursor for the sub list as well. So vector cursor sub list cursor, which is what we had previously. I think we have a flux vector cursor init function for this purpose. We can use, let me see. I think I want to take the actual vector real vector, and then pass that in here instead, just so we have a pointer to what's already there, because we have copied now. At this point, flux vector push is copying the contents of sublist into the parent vector, so we need to use that going forward and not use sublist, because if we do that, we're going to be writing to something that is not going to have a lifetime outside of this function call, because it's allocated on the stack. Okay, so now we have the real vector. Maybe I can rename these variables a little bit. Temp sublist, and then we're going to call this sublist. Okay. Okay, and now we can set up the cursor to point to this this list, sublist, and then the cursor is going to be the sublist cursor, and we're going to use an ampersand for that as well. So now this is what's going to be used for adding things to the sublist. So I think I can get rid of this part. And let's see, push the new list onto the parent vector and set up a cursor. New temporary list that will be copied later. Okay, so now we're going to parse the list contents recursively, which basically is calling the same function now with this sublist cursor. And the sublist cursor is going to be operating within the context of the sublist that we just created as part of that parent vector. So token cursor we do want to pass along, sublist cursor we want to pass along. And then at this point, this is a recursive function call. Once this comes back, we're going to have a handle on the sublist cursor.current, which is going to tell us the ending memory location for the last item in the sub vector. And we're going to tell the current list cursor that we need to use the same location as where the last cursor left off. Now, I wonder, I think that's right. Let me check. This seems to be the wrong thing. Is this current item now? Yeah, current item, because I changed the nomenclature a little bit. Okay, so this seems like it should work. I don't know if it's going to work, but we're going to have to compile it to find out. List cursor to list. So this part's a little bit interesting, because the list cursor is pointing to the actual vector. Let's see, list cursor at this point. Actually, that's probably fine. It's probably fine. So list cursor, we're going to return, oh, no. I remember now. We need to return the expression list, but what we have access to at this point is the pointer to the vector. Which means we're kind of going to have to walk backwards a little bit. It's not terrible, but it's not ideal either. And also, it has implications on the wrapper function that calls into this recursive function also, which I'll show you in a minute. So we can just do it and see what happens. I feel like it's going to be a little bit hacky, but let's see. So what I'll do is cast this to uint pointer t, and then I'm going to subtract the size of the expr header, because what we're trying to do is go from the location of where the list is. Now let's see, where's this vector? Yeah. So location of the vector, we're going to subtract the size of the expression header, which is the size of the field that's right before where that vector lives in memory. And then we're going to cast this back to expression list star, so that we are effectively handing back a pointer to an expression list. Like I said, probably not great, but we'll go with it for now, and we'll see how much trouble it causes. Now, the other thing that I was realizing before is that in this Flux script parse, I took a little bit of a shortcut here, or at least I planned to take a bit of a shortcut where I would not wrap the top level list in an expression list. I would just have it be like a raw vector and return a raw vector. But I think now I probably can't do that. I think Flux script parse does need return an expression list still, so that the logic for this function also works. Because the way we, well, actually, hold on a second. Maybe it doesn't need to work like that. You know, let's go with the way it is for now. Let's see what happens. So I just need to port the rest of this function over correctly. Expert list, top level list. This is no longer valid. I've already converted this part where we're using parse vector instead. I'm creating the instance of the vector for the parser vector, basically. I wonder if I'm resetting the vector. Let's see, flux vector create. I'm curious about what I'm doing in a token code. Oh, okay. I'm actually doing that there too. Cool. Just making sure I'm resetting the vector the same way for the tokenizer. Okay, so we have the token cursor that we're setting up for the token vector. That's all good. Then expression list, top level list. So if we don't have to represent that as a list, then we can probably skip this line. So what we need to do instead is have a vector cursor, list cursor, let's call it. And then, and why does it not like that? Redefinition. Oh, vector cursor is at the top. Let's get rid of that. And then we're going to init that flux vector cursor init. We're going to initialize that to the parse vector, and then have ampersand list cursor because it's a stack allocated variable. And then flux script parse list, we're going to pass in the token cursor and the list cursor. And then once this returns, yeah, this is not even really relevant anymore, so I'm going to take that part out too. And then at this point, I can return the parse vector, because I think that's the way I was thinking about this, is that we can just return a vector here instead. If I go look at all the locations we call script parse, they're all expecting that to be expression list. However, let's see, script.c, we have a couple locations, flux internal. This is the place where I was expecting it. So we're calling it here. List cursor list flux script parse. I think I can change that to just be a vector. So I'll do that in a second. Pedro asked, do you have your Emacs config theme up by any chance? I'd love to try it out. Just look in the description. I have links to my configuration website. And you can also go to github.com/davidwill/.files and find it there too. Okay, I think we're getting close here, thankfully. So for parse, let's just change this usage model instead. List cursor, I don't even know why I have a list cursor passing in here. Oh, is that because of this? Let me think about that for a second. So eval is calling into the, no, hold on. Oh, right, I see. That makes sense. So we're gonna change this to be a vector cursor. And then we're going to init that vector cursor, flux vector cursor init. I'm not getting IntelliSense. LSP cursor init. There we go. And we're going to pass in, which one? Oh, we need to grab vector first here. So vector expression vector equals, we're going to take the result of this. I don't think flux script parse takes anything else, is it? Yeah. And then we will move this function call down. We're going to look at the expression vector in that. And then we're going to use the list cursor that was passed in to initialize. And then we can return the expression vector instead. Is that what we're doing for token header? Ah, okay. So we were simplifying it a little bit. We may have to change how the tests are written currently, but that's okay. So return expression vector, I'll have to change this to be a vector. What are you unhappy about? I mean, compatible pointer types. I need to go change the declaration for FlexScript parse. And I think that's in internal parse right there. We'll see if I end up sticking with this. I might have to do the wrapping in an expression list anyway. I'm considering it. Because it's sort of, let's see, hold on a second. Token cursor. Ah, yeah, that's right. It's token next, tokenized. Oh, okay. Tokenized returns a vector too. So that makes sense. And let's get rid of that pointer star because we don't need that anymore. Token next. That can go away. We don't have that anymore. Okay, so we have both these returning vectors. This should be happy now once it realizes that the type has changed. Yep, and this also should be happy now, I think. Oh, yeah, I need to change this to be not a pointer because it's not a pointer anymore. All right, so parse in this file. This one is expression vector. Yeah, let's go to this next one. All right, so this also needs to be a vector result. And then result. What is the content here? Start item. Okay, that's what we're going to use here, I think. Just return start item. FlexScript parse token. FlexScript tokenize. This returns a vector now, which is a different situation. So maybe I need to call this tokenize function to get the same functionality, but it expects a vector cursor. Let's see. Where was I? So token vector. FlexScript parse, that wants a vector too, so we're in good shape. Token vector. Okay, and that seems good to go. So any other call to parse, they're all the same, I think. I think all the code that calls into this is probably good at this point. Okay, so I'm going to try to compile this. I'm pretty sure I'm going to get compiler errors, but that's okay. I see a 19 up here, which tells me that there's, you know, stuff going on. So we can use compile. I want to do run tests. Oh, I need to go back to the root folder. That's one thing I don't like about compile. It's trying to pick up the current directory. Okay, so at least we have some errors we can deal with now. Probably not too many. I've fixed a lot of the stuff. A lot of warnings though. Okay, so expression kind value undeclared. Script.c270 sounds good. So, whoa, 270 GG. Thank you. All right, so item is value. This part is for expression size. So I need to go change this now to expect integer. Like, once again, the G key is totally missing me. And string. Item is integer. Man. String, okay. Expression header plus, we're not using those anymore. I'm gonna actually steal this little section here for the string because it's basically the same type of logic. And then this is gonna be size of, well, no, hold on. I think this is just plain old size of expression integer because there's no variable length business going on there. What else have we got? So just expected expression 272. Let's keep going because I think that probably fixed that now. 358. Conflict and types for flux parse. Flux script parse. This now needs to return a vector, correct? Yes. Okay, that's how the function is now set up. And I think I can delete a couple of these lines in a minute. All right. And then line 441. Unknown type name expression list cursor. Okay, we got this one here. Yeah, okay, I need to update these existing function definitions. Vector cursor. Yeah, we're going to convert that value type as well pretty quickly here. And this is going to be current item, I think. Okay. Token undeclared. And 488, I think that's gone. 493, expr list cursor. This is going to change to vector cursor. Ooh, this looks broken now. What's going on with that? These things I can do now, I think. Oh, not yet, not yet. Okay. Let's comment those out for the moment. Get rid of the errors. Vector cursor, we're going to init a, let's see. Yeah, we're going to do the flux vector cursor init. And we're looking at a list expression. We need to cast that to expr list first, so we can grab the vector or the items out of it, which is a vector. And arg cursor, maybe cursor is the first parameter of this function. I think it is. A little bit annoying. All right, so let's take that. Are you happy now? No? What's your problem? Undeclared. Give me a break. Do I need to actually put this outside? Maybe it doesn't like the fact that I have this inside of a case. Probably. Okay, let me see if I can move this up here. I don't know why I was able to do that before. Arg cursor. I was wrong. Let's do this. Hey, Gavin. Going pretty well, I guess. You? Haven't had a chance to check out your Lisp video yet, but I'm looking forward to it. Passing struct vector. Okay, so items. This needs to be an ampersand here because we're passing in a pointer. Yeah, that should be good. So now we are not going to use this anymore. We're going to use vector cursor next to grab that item from the vector. All right. I promise all this will be worth it in the end. Okay, so I think we've cleared some things up a little bit. I see a couple errors here. Okay, there's more than I thought. A lot of that seems to be inside of, okay, yeah, a lot of stuff in the test code, which is looking for expression value, which we got rid of. Errors, errors, errors. Okay, so unknown type name. Let's just go find expr list cursor. Where am I using this still? In the test code. Okay, so test code is what needs to be updated at this point, it seems. Vector cursor. And is that enough? Oh, I need to change some function calls. Maybe it's just a matter of changing expr list cursor to vector cursor using some evil expressions. And then also the function we need to update is, or the function call where you need to update is this expression list next. So we're going to change that to flux expr, or no, script expr list next. We're going to change that to flux vector cursor next. Hopefully that didn't break everything entirely. We're going to recompile and see what we see. Seems to have cleaned up a couple things, but we got some issues with expected expression. Oh, that's because a type doesn't exist. That's fine. Expr kind value. All right, so X per kind value shows up a couple places. And in this case, we're looking for a string. Hey, Alex. Your eyes stop bleeding from work code when you tune in the flux harmonic? Well, that's cool. Let's see. So we need to change that to string. Yeah. Wait, hold on. We're looking at the expression. This part goes away now because we don't need that anymore. Expression value goes away as well. So this goes to expression string. Yeah, we got some test code update here. That's a little bit annoying. And we can simplify this expression because we don't need to deal with the value string crap anymore. Yeah, I think this was probably the better idea all along because it complicated things unnecessarily. All right, so get rid of this inner bit and take the ampersand off. Wonder how many of these we have. These checks like that. Circle 1. How many times am I doing that? That looks fine. Okay. Integers. Alex asked, am I using more specific data types? I'm changing the way that I'm modeling expressions for value literals because it was causing trouble with how I was managing memory, and I needed to simplify things a bit. So I think that we're in a better position now because of that. So it also requires to change a lot of test code because I had written checks for this expression kind value, and I need to go and change them to like integer now. So if I get rid of that and get rid of this part here, wait, no, is that right? No, integer, number. I think that should still work. Do I have another value? Yeah, so I need to get rid of this one as well. We'll get these whittled down pretty fast. And integer, yeah. We want to do that. Integer, yeah. I mean, I'm hoping that we'll get back into evaluating call expressions, and then we'll get on to calling some things and getting the circles rendering again. So I think that so long as this thing doesn't crash and burn completely, like the memory management just totally blows up, I think we will be back on track by the end of the stream for sure. Okay, so we got those spots updated. I'm sure there's more. We'll just go look at all of them. Expression integer has no member name value. Yeah, that's right. So we're going to change this to number, which is the wrong name for that, but we'll deal with naming problems later. What else? 271, 271, okay. 270, interior. I did it again. The G key is not cooperating. Don't know what's happened with that. There's a difference between this ThinkPad X1 Extreme keyboard that I'm using for the stream right now and the ThinkPad X1 Nano keyboard that I use all day when I'm coding on, work stuff and whatnot. So I think my expectations of key travel are different on these keyboards. Or I guess you could say they're incompatible. The problem of switching between scissor switches and butterfly switches or whatever they are. Alex uses the washing hands emoji and says it's not for washing, it's rather praying for success. Well, we will be praying here, or cursing, one or the other. So 261, another instance of using expression value wrong. String, all right. Okay, that's also 261. 261. I think we cleaned it up now. Let's see what happens. All right, so that's one error. Nice. Undefined reference to expr list cursor init. So we need to change this to vector cursor init. And we need to make sure this is actually going to do the right thing. So vector cursor init. All right, so the only other places that's being called are locations where expression vector list cursor. Okay, so that's right. And then here we have expr. This is not right because this actually needs to cast down to expr list and pull out the inner items set. And then we're probably gonna have to do an ampersand on that to make it happy because we need to pass as a pointer. I think that's the right thing. Okay, so let's compile again. Another exit abnormally. I think we must be not linking. Okay, script expr list next. Where am I calling that? Flux script expr list next. Right here. And that is in flux script func add. I can change this now to a vector cursor next. And I think that's happy now. Value integer, okay. Let's see what it does. Maybe we can finally get to a place where it compiles and tests run. Okay, good. So tests are running. The tokenizer tests are passing, which makes sense because those didn't change. But the parser tests seem to be having issues. Test lang. So it could just be the basic setup of what we're doing. I'm going to go back into script.c and I'll turn on the parser logging so we can take a look at what's happening. And maybe I'll turn on token logging as well, just to get a lot of the spew, see what we can discern. I mean, obviously I can also go and... Why are you unhappy? Ah, nice. So I've exposed some issues by actually evaluating the stuff in the macros. Holy crap, how many? Vector cursor has no member named list. Great. Let's see. How many times am I doing that? Can I just do a find and replace? Yeah, it looks like I can catch a lot of them. So how about this? Was it list underscore cursor items? No, list. Okay, and then list underscore cursor dash items, I think it was. Or is it vector? We're gonna find out. Is that right? Yeah, I think it's right. Cool, that works. List cursor current. We're gonna change that as well to current item because that's a different thing. Current, comma, because that's how it tends to be used. Current item, comma. Maybe that will appease the issues here. Let's see, how many errors now? Still a few. Okay. Vector has no member named items. Yeah, okay, so items. What does it have? I forgot. Need to go into internal underscore vector start item. Okay, so let's go back to script.c. This is going to be start item. Also, we have another instance of list cursor current, which uses a parenthesis afterward. We'll change that as well. Just a little bit of find and replace refactoring here. Okay, so we got some other issues as well here. Vector cursor has no, oh, sublist cursor, okay. So cursor dot current item. Okay, that seems fine now. What's the next one? Symbol, comma. Needs to be, yeah, in this case, I don't actually want to, interesting. Maybe I need to do it at the current location of the cursor. So, because I want to figure out where this is going to be written in memory. So list cursor current item. That's kind of what I want here. So I'm going to go drop that here and then fix the other pieces. I have to go back and edit those a little bit. There's probably a better, more efficient way to do this with evil, but I don't know it at the moment. Whoops. Go up and delete that as well. Try to compile it again. Should just have only a couple errors left. Yep. Script parse buffer. So script parse buffer that no longer exists. Now we need to use parse vector here. Parse vector. And we also have list cursor.list. List underscore cursor dot list. This now needs to be vector. And list cursor dot current needs to be current item. So I think that we've caught all the issues in this file as a result of using the macros now. Yep. Something else is left. List cursor is undefined. Where is that? I just made that change. 377. Upward V says evil multi-edit is useful for these kinds of edits. I'll have to take a look at that. I haven't used that at all. List cursor dot vector. I think that we have parse vector here, so let me just use parse vector instead. Parse underscore vector. Okay. Segmentation fault. Good. All right, so we're back to where we were. Setting symbol circle. Start sublist. Okay, so that looks wrong. That's a very strange memory address. So when we go in, item is list. Expr in this case. Flux script expr size. Well, that makes sense because that's stack allocated memory that we're passing in, so it doesn't really help a whole lot to write out that memory address, but that's fine. We're going to leave it as it is. Begin sublist, parse list starting at parser got token 3, and then setting symbol circle, setting symbol. All right, so we're here. I'm writing out this current item. Current item appears to be set to 0, so I think I'm not initializing the sub vector correctly. Because it shouldn't be 0 at this point. So flux vector init is supposed to deal with this. It's setting start item, which is interesting. Alex is referencing some old school No Limit mystical songs here, I think. Come on. We are looking at script.c setting symbol circle. So why is it writing 0? Why is list cursor current item 0 currently? This is at the sublist, so the question is, do we init the cursor correctly? We may need to cursor init. Let me go check that out, because I think I don't actually set up the cursor until you do the first iteration with it. So vector.c cursor init. Yeah, we're setting current item null here, and then we use cursor next to initialize it, and we sort of do that because we need to. Cursor next. We need a way to pass around a cursor before it actually has been iterated over once to make some algorithms a little bit more convenient. So that's the reason why we need to do this next step right afterward, because we need to at least get the first memory location set into the cursor. So let's try this now. Okay, so we have a memory location that looks wrong to me. That does not look like the right memory location at all. Let's see. Sub list cursor. I must have done something wrong in how I set up the cursor. So sub list cursor, I'm initting that with sub list, but sub list is coming from flux vector push. And it's the address of sublist, I think, that is going to cause problems. So let me actually write out a parse log for sublist. Created subvector for nested list. All right, so that should be enough to write that out. Let's take a look at that now. Whoops, excuse me. I have to write a little new line there just to make sure that the line breaks. Okay, so created subvector for nested list is telling me, okay. That's really interesting. That location looks legitimate. Because previously to that, we're still in the same sort of space here. We've only added about, well, let's say, what is that, 28 hex to the location, I think. Or maybe that's not 28, maybe that's something else. So that's the location where the sublist vector is, and then the cursor gets initialized with respect to the sublist location. So cursor init, and it basically just sets where the vector is in memory. So we're taking the location of the vector, which is sublist. Hold on. Yeah, that's a pointer. So we've written out sublist. The location looks legitimate. And we've stored that into the cursor. And now we use flex vector cursor next, which wants this start item location. Okay, so that's the problem. The problem is we need to update again the start item location after we do the copy into the new memory location, because I think what we've done here is carry along the old memory location from whenever this was initialized first. So I need to think of a way to make that smoother, but maybe you can say that excuse me, subvectors are not as much of a concern at first. So what we'll do is say sublist. Yeah, this is hacky, but let's just do it for now. Dot start item equals size of, is that right? Let's see, where is just vector plus, size of vector plus 1? Vector plus 1. Yes, okay, it needs to be based on the location. So sublist plus 1. Now, the reason why this works is because pointer arithmetic says that if it knows you're trying to add a number to a pointer, which in this case sublist is a pointer, even though it doesn't look like it, because vector is a type def for a pointer to the underscore vector struct. So this is actually a pointer. When I say sublist plus 1, it's taking the size of the vector struct and then adding that to the current location of the pointer, and we're assigning that to start item. And the reason why we do that is because we are arbitrarily deciding that the vector struct has a certain size, and then we're going to start the actual children to the vector right after that in memory because of the way that we manage the memory ourselves, okay? So then that should get us up to date. Let me run this again. All right, so now at least the memory location seems right. So we got a different segmentation fault, but at least I think we're on the right track. So setting symbol circle. So which part of this is causing the problem? I think we need to write something out, maybe right around here, just as a way to make sure that we're getting to that. Parse log. So maybe what I'll do, expr header, expr final, I don't know. I'm going to parse this, or I'm going to write this out right behind where this thing gets returned, because what I want to see is where the final memory location is for the symbol, final symbol. It's a little bit boilerplate. pushed symbol. Okay. And I'll keep this because we kind of do want to see that. So I'm going to use the actual symbol final. Okay. Final symbol. And I'll make this the actual expert symbol so that we can make sure that we can read it whenever it comes back. So let's see. Expert symbol has no member string. What is it? Name? Yeah, name. Name. Run it again. Come on. GR. There we go. All right, so it doesn't get to that setting symbol. Curious. So it means something about flux vector push is crashing. So now we're just going to jump into GDB and check it out. I want to run tests. Run. Come on. Run. Okay, so we're at the item size function. And what's the backtrace? Flux vector push. Yeah, I know. I'm there. I'm ahead of you, and I'm in the future running GDB. Let's see. Flux vector C77. Maybe item size func hasn't been set correctly. Huh. That is likely. I think I missed that in setting up the vector. Did I do that right? So up here, I think this is wrong. Something's wrong. Flux script X per size. Okay, that should be right. But it's crashing at 77. So it must be something before that. Let's check it out. So flux vector push. Where are you? Push 77, right? Where did I see that? 77. All right, so right around here. So maybe cursor vector is the one that's not right. Can I take a look at that? Cursor? Disp or P cursor? Okay, vector cursor has a location in memory. Cursor arrow vector has a location in memory. Can I see? Yeah, it looks like it could be right. F68, F68. Parse list starting at. That seems correct to me. Yeah, for F68, that's actually a vector. So who is unhappy at this moment? Segmentation fault. Cursor item. Let's check item size func. So P cursor vector item size func. Okay, that it appears to be pointing somewhere in memory. I'm guessing that's legit. I could try to call it at that. I think that works. Cursor vector item size func. Can I call like this? Undefined command. Help. Running the program. And I like evaluate an expression. GDB eval expression. Hi, yummy. Calling. Here we go. Calling program functions. Call expression. Okay, so let's do that. We're gonna do call. Valid character. Fine. What am I looking at? Okay, so calling that function segfaults. Maybe there's something I'm doing in there, and for whatever reason, it just doesn't track it correctly. So let's go back into this function. And we will print something out here just to be sure what's happening. So parse log We're going to put in the expression as the location to log out. Checking size for kind. Now, we'll do this. X per kind. And let's just see what happens. We'll get out of this. And then go back into the compiler buffer, compilation buffer, run it again. Okay, so it did not get to that point. Maybe it's because I didn't put a new line, it just didn't flush fully. Let's see. Yeah, it didn't get there either. So, is it a problem that I'm calling that function? Or is it a problem that something like even... No, let's not grab kind. Let's just comment this out for a minute. And see what happens if I don't try to reach into the object. Still don't get anything. Let's go back to GDB. Okay, so still in flux vector push. It just doesn't make any sense because everything I'm touching at that line seems correct. Void pointer. Okay, wait, hold on. Yeah, I think that's probably right, isn't it? FFFE7770. No, it's a little bit different location. Set a breakpoint somewhere and step through the code. It'll let you look at how things change as the code executes. Yeah, I probably need to do that. Let me think. Definitely inside this function we'll do it. But didn't expect this part would take so long. But that's sort of what problems I'm getting myself into here with doing things like this. Okay, so we're going to go back to script.c. I just want to take a look really quick at how this is going to happen. Expr size. Flux vector init. Hold on. Maybe I'm not looking at the right one. Temp sublist.items. Expr list. Yeah, we'll take a look at that. Just trying to double check my thought process here and make sure I'm not doing something really dumb. So expression kind list. We're setting that on the temp sub list, which is stack allocated. We init the vector to populate its properties, and we include the function as part of that. But that part should be fine because it doesn't change whenever I do the copy. It's still the same pointer. Flux vector push. There's a couple things that could be going wrong here. List cursor, temp sublist. Yep. Okay, so we're copying that. We save that as sublist. We reset the start item location. So created sub vector. And it begins sublist parse at 6.8. List cursor current item. Okay, so all of that looks good. Alejandro says, within a case statement, you're passing expr for integer, but for string, you are passing token. Could this be it? Let me check that. Let's see. String, I was passing token. I don't think we've even gotten to that point yet, because we're using... Let's see, let me just double check what I did, just in case. Token string, everything looks normal here, so maybe this is all fine. Oh, in the case, yeah, that's another part of the code. What about up here? All right, so that is wrong. I don't think that's a problem, but that's definitely wrong right there. We'll run it again and see what happens. I'm pretty sure that's not the issue though. Yeah. Okay, so symbol, keyword, integer, string. I'm gonna move this closer to the others because it's so similar in pattern. Okay, everything seems fine. Like I've spot checked the code. It looks right. So maybe I'll do what Felipe suggests and try to set a breakpoint. And I'll do that right about here, because this is where we start calling it a flux vector push. So I could say good break, set a breakpoint at that line, go back into good shell, hit run, start it from the beginning. Source file is more recent than executable. I changed it. I need to rebuild that again. Okay, so let's go to compilation. We're gonna compile it, go back to good shell, type run, start from beginning. Now we're at the breakpoint right here before flux vector push. Let's see. So symbol that we're about to push, P symbol. Let's see, kind symbol quoted, the name. Let's think about that for a second. Yep. Seems fine. You know, doing a copy on this though is a little bit problematic. It's like I have to do a post-processing step for anything that has extra data. We're gonna find out in a second what that means. I don't think it's actually part of the issue we're looking at, but it will be a problem right after we figure out what is happening next. So let's see, what's the, okay, step. Okay, so just S. All right, so we're gonna step through the code. We're now in flux vector push, step, step. All right, so now there's a point where it's gonna try to call this item size func. I'm gonna try to write out what cursor dash vector is. And then item size func. Okay, so step, boom, immediately crashes on that call. I mean, this memory location looks a little bit fishy. It's so big, but it could just be because it's where the functions are defined. So it could be garbage or it could be real. So let's try that one more time. We'll take a look at it earlier in the game. Let's go to flux script expr size, p flux script expr size. Size t void pointer flux script expr size. And then we will continue. It must be because this pointer looks completely different than what I'm expecting to see. So the question is, yeah, all right, let's do it one more time and we're gonna inspect the, here, this is the right way to do that. Let's run it, start from the beginning. So we're right here, we're gonna look at the memory location for expr size, okay? And then also we're gonna look at list cursor dash vector dash item size func. All right, so definitely indicates to me that this memory location is not set correctly. Did I not assign that? I think I'm just not initializing it right. Item size func is item size func. So what if I set a breakpoint here too? I guess the problem is vector init. Okay, I'll set a breakpoint right before I do the sub vector init. Vector init. Let's set a breakpoint right here. And then we're gonna run it over again. All right, so here we're looking at p flux script expr size. No. Expr size. Expr size. Okay. So we've got that there. And now if I step into the code there, what is item size func? Same thing, I think, right? Yeah, CF. It ends with CF. So then let's move it down a little bit. Let's step a couple times. And now let's write out what's inside of vector item size func. Okay, so that's right. All right, let's keep stepping out. Huh. I wonder if something I've done to the vector itself causes it to be overwritten. I may have to add a watch point, that's for sure. That's probably the quickest way to get through this now that I've sort of seen where things are coming from. All right, so vector, so this is, what is it called at this point? Temp sublist. Let's look at temp sub list dot item size func. There's no member named item size func. Why not? Ah, because it's expert list. Oh, okay. So what's it called? Vector dot. Come on. Temp sub list. I know I have something in there for that. Items. Okay, still 8CF, which is the same location. Now, let's head down a little bit more. Flux vector push. We got back in here. Let's write out. Yeah, we're pushing this expr onto the parent vector. So we're okay here. Can I use like a help you? Whoops, help you. Until, how do I jump up? Because I want to get out of this function call. Running the program, help running, advance. Was it like next? Ah, still the same thing. This is all happening in the parent list. That's all good for now. Man. Yeah. Okay, so flux vector cursor init. So now we have sublist. Let's take a look at, let's print out sublist arrow. No member name item. Sublist. That can't be right. Oh, no. Sublist is a vector. Yeah, okay. That's right. Let's do this. Yeah, so at that point, it's already screwed. Somehow, upon copying that to the actual vector memory, things got messed up. What else is in there? It's kind of opaque. Let's see, start item. S steps into functions, N does not, thanks. That location seems right. Yeah, that seems right. What else we have? Length. 0. So nothing else got screwed up except for that function pointer location. After the mem copy. So let's go back into vector.c, mem copy. Item size. So I'll take a look one more time at internal. So vector. The item size function is a pointer at the very end. I mean, it should be copying that. I don't see why it would get it wrong. Okay, so here's what we'll do. We're going to try and just be very explicit about this since we already had to do it one other time. Let's do this. I want to try this to see what happens. Gavin says someone try to compare C# to Lisp saying they do all the same things. That doesn't sound right. Item, size, func. Flux, script, expr, size. We're going to actually make sure this doesn't get overwritten, but let's just check and see if this actually helps. Okay, cool. We actually got through an entire parse. Or did we get through all of them? Tokenize. Okay, that's segfault. Okay, segfault. Fine. Okay, we parsed everything. So somehow that's getting overwritten, and we're going to figure out why. So let me just add a little to do here. Figure out. And we're going to come back to that because I don't want to spend too much more time. We've already been here an hour and a half, and we haven't even got to the good stuff yet. All right, so the test failed with a segfault. Let's go into good shell again. We're going to run it. Source file is more recent than executable. That can't be right. I just compiled it, didn't I? I added a comment. Okay, so we need to clear out some breakpoints because we don't need those anymore. Was it B? No. What is it? Info B? Yeah, okay. And is it del help del? Yeah, okay, there we go. Del. Yes, let's just delete all breakpoints. Okay. I will compile one more time. Compare a ThinkPad to a Turing machine. It's all the same. Yeah? Okay, so let's go back into good shell. We're going to run again. And backtrace all the way down. Okay, sprintf is unhappy. I'm guessing that probably I've got a format param wrong inside of test lang. Line what? 242. Okay, vector cursor next, list cursor. So that's interesting. How about we write out printf, oops, printf, got expression, let's get the memory location. Because I think something in the macro. I'm printing. Oh, hold up. Well, that's not even right to begin with. What did I do that for? Assert eq. I guess I was supposed to be checking integers with that. Okay, well, that's wrong. I don't know why that was never a problem before, unless it just got inadvertently changed somehow. Let's go back to compilation, recompile. Okay, so printf, there we go. Let's just drop that on there too. Oh, that's not good. I think we must have gotten past that test though. Yeah, good. Expected value 1 got 7. Okay, so that's something. So we got to the second parser test. We got a lot of spew out here, but it is pointing out that we've got something wrong for handling an integer. Oh, that's why. Because I think we... Well, we'll check it out in a second. We haven't gotten to eval yet, so the value integer doesn't come into play. That memory location seems wrong. Parse. Item is keyword. Yeah, this seems like it, it's got the wrong memory address. The hell did I do? Okay. Flux vector cursor next. This is a cursor that should have been initialized. But is it the wrong place? I wonder. Let's go back to the definition of parse. X precursor parse. Oh, do I? Hold on now. Okay, that's right, because we're initializing it after we get the vector back. So it should be a fresh cursor at this point. Let's actually print out start item and then cursor at. Well, cursor at won't give us anything. Well, let's do it here and see what happens. Oh, haha, no wonder it didn't print out the right address. I didn't put the expert in there. Okay, so that explains that. Cursor at list cursor current, no, current item. I need to make this a dot because this is a stack allocated variable. And for here, start item needs to be list cursor. Hold on. Yeah. Vector. No, it's a dot. Dot vector arrow start item. Okay. Let's take a look at what that says now. All the way back. Okay, so F68. What is that supposed to be? Sub vector for nested list. Parse list. Parse get token 3, 5, 1. Seems like it's the right place. Outer list will resume at AB. What is the kind? Expected value 1 got 7. Why would it be 7? It's not even valid. Unless, let me think here. Cursor next, list cursor. So list cursor is supposed to be setting things up. The first thing we would see okay, let's also get the vector location in memory too. Sorry folks, I know this is like not what you would want to see today. This is why I gotta improve the way these things work, the streaming. Okay, so vector, that seems reasonable, actually. That seems right. The start item would be at that location based on what I've seen before in the code, in the logs. So the question is, why is the value wrong at that location? The kind we're looking for says it's 7. 0, 1, 2, 3, 4, 5. Is that right? Am I counting wrong? 0, 1, 2, 3, 4, 5. There's only 5 in this enum, so 7 is totally out of left field, which means something is wrong. Maybe I need to set a breakpoint there and try to debug that. So right about here, set a breakpoint, go back into good shell, run the code. Okay. P_expr expects an expression header. Kind is 7, which is totally wrong. What could it be? We're very close, I think. It's just the small little issues. I also think I feel like there's a mistaken assumption somewhere also. The first thing that comes out of the vector should be a sublist expression, for sure. If we go back up, parsing start, parse list starting at 48. Parser got token 1, that's opening the list. Now, I don't know why these are two different values. Let me take a look at that really quickly. Script.c. Parser got token. Okay, so here we're writing out the vector location. Whoa. Okay, yeah, there's still 40. All right. Parse list starting at the start item. This is the actual start item of the vector. And this is writing out the token kind. No, the token as the memory location, which is even more confusing because they seem to be pretty close together in memory. So that is a bit of a red flag. Token 1. Oh, okay. They're not actually that close in memory because we have the A versus F here. So they're definitely not that close. F40 is where we are for the vector itself, and the start location is at 48 for the start item, which seems possibly reasonable. And then create a subvector for nested list around 68. Nested list. Wonder if anything else got corrupted there. And then when we come back out finally, finish parsing top level. So that's at 68. Token 4. Yeah, 68, 68, 68. Outer list will resume at FEO. Yeah, it seems okay. Hold on a second. Yeah, okay. So we're starting at the location where the inner vector left off, and we're continuing ahead. Exit list parse. Exit list parse. Okay, so we're not doing this anymore. So let me just take that part out. I don't need those markers anymore. List cursor. We're setting up the list, and then we're coming back with a parse vector that we're returning out of it at the end. Very strange. So let's go back into TestLang 245. So this is the point where we're getting something wrong out. Let me just try to inspect stuff that's in a vector. How about that? So P list cursor dot vector. So that's a vector. Length. No. Can't be right. That's definitely not a vector with length of 1. No. Hold on. Wait. It is a vector of length of 1 because there's one expression in this list. So are we missing something? So next is going to give me the expression inside. I have access to that right now, right? So P expr. We're expecting that to be a list expression, but it doesn't seem to be. What if we cast it? Does this work like this? Expr list. Expr. What about items? That seems like garbage. Definitely not right. Whatever memory location we're at is not giving us the right information. How about this? Let's check list cursor current item. And then list cursor vector. Wait a second, hold on. List cursor is not a pointer. So how did that even work? Okay, start item. We want start item, and we also want list cursor current item, which appear to have the same memory location. Start item and current item, even though we've already... no, that's right. That's correct. So start item and current item should be the same because this first call to cursor next should put us at the first item of the vector. So then the interesting thing is it tells us that it's got a type of 7, which shouldn't be the case because it should just be a list. The first thing we should get should be a list, expression list. So I wonder if the data is being written to the wrong place to start with. Yeah, this is really annoying. Now the thought comes to my head about whether I should pause this part of the work and move on to something else so that we can make progress. At least to getting the circles rendering again, because I think I'm gonna have to do some more deep debugging in this. I mean, it could be that I just go ahead and try to finish debugging this at the until the end of this stream session, but I don't know how boring this is at the moment because I'm just sort of scratching my head the whole time. So let me know your thoughts in the chat if I should keep with this or maybe move on to something else. In the meantime, I'll continue thinking about it. So what I expect to see is that they are the same location for the start item of the vector and the current item of the cursor because we've only iterated once, which puts us at the location of the first item. The question is the first item the one we expect it to be? F68. F68. Parse list. So when we write this out, parse list starting at F70. Parse list starting at. So we're in a call to Flux script parse list. So we start at the very beginning, like the top level parse is starting at F48. We find an open parenthesis right there, token 1. Start sublist, that's how we know we're going to go into a sublist. And then here, created subvector. This is when we have the sublist we've already pushed onto the vector. So we get the location of F68. And that's the one we should be looking at. Now, maybe, hold on a second, wait. I'm doing something wrong here. I think the problem here is that I'm pushing expression list, but I'm treating it as a vector when it comes back. So let's do this. This must be the problem. Expr list, sublist, okay? And then this should be oh, this is exactly why we're having the problems we were having. Because I wasn't dealing with the vector directly. I was overwriting everything, it seems. So let's do this. Let's get rid of these two lines. And Nicholas is giving me tips in the chat, and he realizes he's not watching the current of the stream, which is something that happens with YouTube streams. Okay, so sublist, we need to treat it as an expression list instead. And then when we push that on, we have the sublist cursor, which needs to go against sublist arrow. Was it items? Yeah. Yes. This might fix all the problems we had. Let's find out. Go to compilation. Okay, so we got something he doesn't like. Sublist arrow items, invalid argument of type arrow. Oh, no. This needs to be a star for sure. So we're getting a pointer back. Still a problem. Why do you think that that's returning a vector? flux vector cursor init. It needs to be an ampersand. Yeah. Okay, I think that's better. Huh. So we're still back to where we started. Let's think about this for a moment. Setting symbol circle. So this also all of a sudden has a wacky address, but this definitely was wrong. So we have the stack allocated expression list variable that we're initializing here, but then we push it onto the vector, which returns a pointer to the real location where it's going to live in the vector, and we still need to treat it as an expression list. So now we have that expression list variable back. We're printing out created sub vector, so we have the expression list for the sub vector at that location, which seems like a real location. Flux vector cursor init, we're passing in the location to the vector struct. We can say here vector at x to make that clear. So we say and sub list items, just so we know for sure where. Well, hold on, wait, hold on. Items is a pointer. Boom, that's gonna fix that problem. So let's clear that out really quickly. It doesn't like it. No, that's right. It needs to be ampersand. Yep, unfortunately that's the case. Let's go here, run that. Just need to see the output. Vector at 70. Okay, that seems correct to me. I think that's right. Set up the cursor, give it the list, the vector, the cursor object. Then we iterate to the next location. Maybe we can grab that and see what it tells us. So expert header. Is that what we want to do? Actually, no. I think we don't want to do that. I think we need to let the recursive call do that. If I'm not mistaken, cursor next has next, and that gets cursor next for token. Excuse me. Okay, I think that's another problem. Man, so many little issues here and there. Okay, so that, okay, so still a problem. That's 0. It hasn't been initialized yet, which is weird. No, actually, maybe it's not weird. Setting symbol. That's fine. It's okay for that to have 0 right at that point. Because here's the point where when you call push, that is going to set the current item if it hasn't been set already. What is current being used for in this? Okay. So let's check what the segfault is. I'm going to compile this one more time just to make sure everything's up to date. And then we're going to go back into good shell. We're going to run the program again and then see what the backtrace is. Flux vector push. We're back to this old gem. What is happening with the pointer location of the function? Something is wrong with how this is being set up for sure. Let's check out sub list. Okay, so let's print out, what are we in? Hold on. Vector push. Yeah, I think it's trying to just call some random ass location. And if we go into flux vector push, flux vector underscore push, we get to line 77 where it tries to calculate that size. Let's actually see. Print cursor. Oh, I may have to go up in the stack frame. Vector item size func. Yeah, no cursor in the current context. How do I go up one in the stack trace? There was a command for that, and I forgot what it was. Help stack. There we go. Stack. F. We want to go to stack frame number 1. F1. Let's try to print that out one more time. That looks like what I saw on the stack frame. Yeah, so that stack frame is calling that function at the wrong location, I think. And that's the value of this pointer. What else is in the vector? What about start item? That's also a BS location. So something is wrong with the vector that's assigned to the cursor. We're pushing temp sublist to where the cursor currently is. C is hard. That's what Bill says. Yeah, C is hard. Especially whenever you're doing stuff that's really, really weird. Thinking. Flux vector push. We're pushing the temporary sublist, which does a mem copy. Maybe I should examine it a little bit after I finish. Well, no. Push. Things are already broken by the time I call this. So when I call this, it just bails out completely. I think. Where am I in the whole scheme of things? Arnav says, have you tried South Indian food? Honestly, I don't know. I've eaten plenty of Indian food, but I have no idea what region it's from in India. But in general, I do like Indian food. Parser got token 3. So we're starting with a sublist. Parse sublist. We actually get into the recursive call, it seems, I think. Again, sublist parse starting at, parse list starting at. Yeah, that's right. Okay, so we do get into the recursive call, and then we find the symbol. And then we try to push that onto the sublist. So we're in the sublist. The sublist itself is not configured correctly. Expert list, sublist. There's just something really obvious that I'm doing wrong here, for sure. The vector is at sublist items. I'm using ampersand to get to the actual location in memory, which is correct. So, and I was using flex vector cursor next before, but I think I don't want to do that. Let me just write some stuff out here, because I think I need to have a little bit more insight into what's happening. So, and sub list items. This is the sub list vector. And what else do I want to pull out of that? Let me look at func. Put a new line. Sub list items dot. Is that going to be right? No. I don't need to do that right there. Items dot item size func. I'm pretty sure that's going to parse. Oh, let's go to compiler. Okay, so this is the sublist vector. Yeah, that function address looks wrong already, I think. Where did I set all that up? Over here. And I'm also going to write out the real location. I mean, I can do that in the debugger, obviously, but better to just sort of just see that written out. the real size func location is. And then we're going to write out flux script. Let's see, flux script. I see Fade talking about what I'm doing here in this System Crafters chat. Let's see, flux script underscore, it's expr size. Okay, let's do that. The real, yeah, so I'm getting two totally different locations, which makes no sense. So something about the mem copy is jacked up. Am I just like getting mem copy totally wrong? Mem copy. Okay, whatever. Destination source. All right, let's go back into vector.c. The push function, we're doing mem copy. Oh, hold up. Yeah. Cursor current item. Yeah, that's the right destination location as far as I know. And we're initializing the current item location if it hasn't been done already. So that should, in a sublist scenario, we're trying to push the first item. We should get the start item location correctly placed in current item. We're mem copying to that location from the item that's being passed into this function. And then we're using the item size that's being returned by this item size func, which is item size out of bounds? Well, problem is we're not even getting item size yet because the item size func pointer is busted. So let me think back up one level of the stack. We are in the parent vector. We're pushing in this new expression list for the sub vector. Ooh, let's think about that for a second. Hold up. So how are we calculating size? I think I may have missed something here. How are we calculating size of? Interesting. I think this is an explanation for why it's not working. So script.c. Haha, yes, okay. So yeah, I did not update this part, which explains it, because in the parent vector, we're pushing a new expr list into the vector. The size function is calling the size function to see how big this expr list object is, and I'm returning 0. So I think I'm overriding memory because of that. I'm not moving the pointer ahead at all. So I'm overriding the vector itself. Fantastic. Okay, so Gun says, didn't you install the man pages? Yeah, let's see. Whoops, man. If I put it right on, let's see, where is it? We were looking at mem copy man. Yes. No, I don't think I have the man pages installed. I think Geeks is probably foiling my plans there. Okay. Hold on, I'm just doing a little bit of spam in the IRC. Twitch TV/Flux Harmonic Live. Okay. So back to it. We need to fix this function. Now, I think the reason why we never got back here is because I forgot about the whole thread of what we needed to do. To get the size of the list, I need to look at the bytes that the vector inside takes up. So I need to return size of expr list plus the number of bytes. And we're gonna have to convert this to, well, I wonder if size of will let me just add to an integer. So expr list plus the expr list star expr and items, and then buffer size. Now that should give me the correct size if I'm managing buffer size correctly. So I would like to actually see what this is going to return before we get too far into it. So let's do this. Presumed size d plus d. I wonder if these are going to be compatible. They may need to be longs or something. And buffer size is size t also? Yeah, I think these are going to be longs. Let's put L for both of those. I'm going to grab that and put that there. Okay, then we will see what happens. I think we got further this time. Yeah, we got further this time. And that looks right. So it's actually adding items correctly. So I think... Whoa, why is that not printing? Could have swore that %L is a correct formatter for longs. Okay. So size of expression list is going to be the size of the header, which is just the kind basically, and some other stuff, plus the size of the vector struct. And then we're going to get the buffer size, which is basically just the number of, or the width of what's there. And I think I'm not taking it into account. Shouldn't matter too much. Buffer size, initial size. What is initial size? No, hold on. Buffer usage. Usage is the right variable for that. Buffer usage. We'll go back into vector.c. Plus item size. And okay, let's not do that. Put it to 0. We want it to be like what actually is being used by items in the list. This probably doesn't help. Yeah, we're still at the same place, but... All right, setting keyword X, checking size for kind, item is keyword. I think we're doing better because we are actually... I'll tell you why, Alejandro. We're actually making it past where we were before. Now let's see what the segmentation fault is. Alejandro asked why there's a 0 here. That's because at the time this line gets written, the current item pointer in the cursor is 0 because it hasn't been initialized yet. But as soon as we try to push something into the cursor or push something into the vector at the location of the cursor, it will initialize that location, which maybe not the best way to approach that, but that's how it works for now. Let's go into GDB. Run it again. Backtrace. We're still looking at the same old crap. And for some reason now, the function pointer we're trying to invoke is at a very weird memory location. Okay, let's go back to script.c. Man, we're really just killing time on some worthless stuff here. Sublist. Hey, Fade. Okay, sublist start item. We don't want that anymore. I'm pretty sure those shouldn't be needed. Let's go up one level in the stack. Was it F1? And I want to print out the... What's it called? Expr? No. Item. Expr header. Item. Yeah, can you tell me a little bit more about that? About like the kind and stuff? integer. And that tracks because we have that there. So why is the item size function crashing? Or why does it get the wrong location? All of a sudden, it's just wrong. So that tells me that we probably need to set a watch point and see if it's getting overwritten somehow. Something bad's happening. All right, got to go back again. Go back to script.c. Since now we've reached the integer part of the game, what came first? Okay, so there's first thing was a symbol for circle. We pushed that on. See, parser got token 3. Checking size for kind. Let me check what I'm printing out there. Checking size for kind. Yeah, at this point, this is a stack allocated variable, so it's not gonna look good because this is not the range of memory we expect to see a variable coming from. But that's fine. Pushed symbol circle. Now, why does this look different? Let's see, pushed final symbol. Yeah, that memory location is totally wrong. Final symbol should have pushed something with respect to the vector location. So where did they get off track? This part is fine. Checking size for kind. Item is symbol. That's coming from, yeah, it's coming from inside of the size function. And then this symbol name is reading correctly, but the location of final symbol is completely whacked out. So what we might need to take a look at here is if we set a breakpoint on that, run it again. Out of date. Let's go compile. All right, then we're gonna go back into good shell, run it again. All right, so now we are right here where we wanna be. Print the list cursor. Can you give me like the contents? How's that supposed to work? Oh, no. Star. Thank you. Okay, the index is totally wrong. How did list cursor get so stupid in this? Something's wrong with list cursor. Yeah. How did it get way out of place? Oh, is it because? Okay. I probably should let's check the stack. Parse list, parse list again. So if we go up one level in the call stack, F1, and then look at list cursor, that looks legit. What about the sublist cursor? Okay. Oh, it's not a pointer. Okay, so the sublist cursor at this point seems to be completely uninitialized, like it's got garbage in it. And can't be right. Vector, cursor, init. Because we're setting stuff in there. Vector, cursor, index -1, vector, vector, current item null. The only thing I see... Oh, okay, that's bad. Real bad. I think index is a uint, and I'm setting it to -1. Jeez, okay. That's real nice. So that cursor is legit. You know, it has the right behavior because of overflow. It just looks wrong. Well, I can't imagine I'm ever going to have an index that high anyway in a vector. I mean, that would be kind of ridiculous. So probably I can just make that a signed integer for index instead. Just so we don't get completely confused. So was it length? Index. So length can definitely be unsigned, but for cursor inside of, what is it, flux internal? No. It's in flux.h when it needs to be moved. The cursor has index. We're going to make that an int 32. But that doesn't actually help with the problem, I think. It's just makes it not look so strange. Yep, so we're still at the same place we were at before. I'll run this one more time, start it from the beginning. And then what I had done is try to print out the list cursor at this location. So now index is -1, at least it looks right. And the vector location seems to be right. Begin sublist parse. Current item is 0. So now we're going to step in. Come on. Let's see. P item. Okay. At this point, that should be a pointer to an expr symbol. Yes. Okay, so that's right. And also the vector inside the cursor. Cursor arrow items. Is that right? No. Vector. Vector. We're going to dereference that. And buffer size is totally wrong. Length is right. Item size func, I think, is wrong. CF. Oh, no? Okay, those seem right. CF. So can I continue then? Maybe I can continue. Oh, God. Yeah. Just trying to think a little bit about why all of a sudden this would be giving me back something wrong. Possibility. The fact that this is a 40 right here makes me wonder if we're accessing a wrong memory location that possibly points to even like a character, because 40 is probably in the ASCII character set range. Maybe. Can't remember for sure. So it's trying to dereference a pointer that is at a memory location that is pointing to some other data type. And the question is, how do you get there? Well, probably the way that you get there is that you have done your math wrong. Everything seems to have been fine up until the point where we got to an integer. And before that was a keyword. So let me check the size function for expr size list symbol keyword. Keyword, keyword, keyword. All that seems about what I would expect. Negative indexes are tricky. See ya, Alejandro. Thanks for being here. Let's see. Negative indices are tricky if int a10 and p a2 Yeah. Yep. Am I doing that somewhere? All right, so symbol, keyword. Oh. Okay, this part is not right. This should be string. I don't know if that's the problem, but it could be a contributor. Let's go back and run compilation again. Okay. Keyword. Okay, this time we didn't get to the number, which is even more strange, but potentially a clue. Yeah. Keyword X. Let me see. Where are we in the test lang C? So we've made it. Oh, okay, so we got past the string here. That's kind of interesting that now it's caused trouble. Where before it got past that. It got to 200. So now we're at keyword where it starts to get confused. Let me double check what the actual seg fault is, because maybe I'm wrong about what it is. Okay, so continue. Backtrace. Okay, this is different this time. Line 83 in vector.c. Vec 83. Okay, so at this point, vector probably is not set correctly, and it's crashing because it can't dereference vector correctly, which is even more weird. And it makes me think that the cursor itself somehow could be getting overwritten, which seems very strange if that's the case. So I'm highly questioning at this point the way that I'm doing all this memory management, because it's just way complicated and super prone to issues. You try to abstract it a little bit. I mean, it was all working before, but it was going to be limiting my ability to do evaluation correctly. So I'm now starting to consider the possibility of simplifying it drastically by just going to a more linked list style approach. And I'm not going to do that right now, obviously, because it's just too much churn. And we only have about 25 minutes left, if that. So I'm considering what we should do. I mean, it's also possible that I could just figure it out. Make sure I'm not hearing myself on the stream somewhere. It's possible we could just figure it out if I just keep looking at it. So maybe I'll just keep looking at it for the rest of the time, and then we'll see what happens. But yeah, I'm very disappointed with the lack of progress on other tasks because of this whole set of problems. Flux vector push. Line 83. Well, we've got the stack here. We can take a look at what cursor vector says. 40078. Doesn't look right. We've never seen that memory location. So somehow even that got overwritten. And if I were to dereference that, it's probably just going to give me a whole bunch of garbage. Link 3 seems somewhat reasonable, but everything else here does not look reasonable. Fade says, for the record, I think this is interesting. Yeah, maybe it's interesting for you. For me, it's a hell of a headache. But I'm glad to hear that it's interesting for somebody, because to me, it just seems like a whole bunch of boring mess. All right, so let's take a look at the cursor as well. So I need to dereference cursor. Okay, so index 4, vector, wrong location, current item also seems like the wrong location. E7D0. E7D0. Setting keyword X. Yeah, that's the stack location. So why is, man, something really messed up has happened here. Must be obvious too. Let's go back to script.c. I want to look at what happened before that. Was it the string? So we haven't really looked into how the value setting here has worked so far. Maybe I'm doing something really stupid. So we got to string, setting string. Wow. Oh, well, that's dumb. Need to fix that. That's definitely not the problem, but it helps debug things correctly if I get that printing right. Setting string circle 1. Arnav says my head hurts too. Yeah. So circle 1. That's all good. Item is string. Hold on. Item is string. And we didn't print anything else out. I think I need to go and copy some of what I did right here so that we can see what's happening with the memory addresses as it comes out. So let me just do this really quickly. So expression, string, final string. It's a little bit too much diagnostic stuff for my taste. String, final string. Oh, come on. Final string, string, right? Pushed string. Let's see. We'll go here to this string. Okay. So let me try to run this again. What? Keyword name. What the hell? Oh, whoops. Let's get rid of that part. All right, push string circle 1, and that's at location BDD0. Setting string, push string. Wait now, hold on. Setting string circle 1. What is that? Oh, the current item location on the cursor. That's right. Okay, that's good. What about these others up here? Current item, current item, current item, current item. Why does some of this other stuff look totally wrong? Partially got token 2. That's fine, because that's actually in the token memory location. Circle 1. Item is string. Pushed circle 1. Okay. Let's delete checking. Yeah, let's get rid of that. We don't need that anymore. It's just noise. Item is string. Push string circle 1. Okay, so now parser got token 4. That's the token location in memory. B0. Setting keyword X. Item is keyword. How did that move? That shouldn't have moved. Keyword. Flux vector push list cursor. Something here seems wrong because setting keyword tells us the current item location for list cursor is 86C0. And then here, item is keyword. That comes whenever we look at the expr size function. And we see item is keyword. The location of expr is EC. And that is a stack allocated variable. So we're like writing to the stack memory space or something right now. I don't know how it even got on that track, but something got it really off. Item is list, subvector, vector at IC. Yeah, something really obviously wrong is going on here. Real size function location, those two match up. Sub list parse. Okay, so item is symbol, pushed symbol circle. And then all of a sudden, boom, we're off in the wrong memory space. So pushed symbol circle. Flux vector push. Something's really, really wrong here. List cursor current item. This is a pointer. So let's look at flux vector underscore push. Cursor vector. Yeah, I wonder if this is what's going on. Is start item wrong? Oh, shit. It is wrong. Ah, that's the same problem we saw before. Okay, now I know exactly what's happening. This right here needs to happen again. So sublist vector dot start item. I think that's the right way to invoke that. I think this is the problem. If I just get it to be the right sublist. Expert list has no member. Oh, it's items. Items. Okay, so we made it all the way through parsing. And where did we get to? Let's see. All right, we actually made it through parsing one of them, which is great news. Tokenized expressions. Start item, cursor at, got expression, parse item is... Why are we seeing more of these? Oh, it's iterating. Okay, all right, so we are building a list mostly successfully here, which is great news. Let me take a look at what's going on in the test file. So all this spam can go away right now because we've validated, at least it gets down to this point, 200. And I must be doing something wrong here. So is this real? Yeah. Number 200, expression integer. Let me check out expression integer really quickly. Int number, okay. And I think I've got this backwards, don't I? Value, oh, it's looking for a value integer. Okay, so what if I do equal instead here? Okay, I'm gonna have to go double check these. I think this test is gonna pass now. I think so. Is that the right one? Yeah. Double check. Int value. How have I got all this backwards? Yeah, okay, that's right. Okay, so let's get rid of this. Equals -15. Let's get one test passing, and then at least we can feel like, you know, some success has been had. No. Item is integer. Let's see, string, keyword, integer, keyword. So we're pulling something wrong somewhere. I think, the keyword check, is it wrong somehow? Sub, list cursor, expression kind, keyword. Let's pull up the good old debugger. Run that. Backtrace. Parse list. What? What? We got through this before. What the hell's going on? I'm really confused. Do we have some kind of like random memory issue? Holy hell. Oh no. Token. Yeah. Parser got token 3. Dude, what is happening? Oh, I'm at a breakpoint. Del, let's just get rid of these. Yep, continue. Okay, BT. Parse list 284. Oh, okay, fine. That is no longer relevant. And we're also going to do this where we say 0 and flux vector cursor has next sub list cursor, which needs an ampersand. Let's check that really quick. That would be really cool if it did work, but we're going to find out. Compilation. Okay, I think we made it through that. So much spew. Kind of necessary. I should probably take the token stuff out. Oh, still tokenization. I think it was in there. It must have been in there. I just couldn't see it because there's too much garbage in here. Tokenize. Come on, dude. That 311 is not even in this test execution. So which one is this? We're almost there, folks. Eval. Oh, we're even an eval integer? How do we get that far? Can't be right. Did we make it all the way through all the other parse functions? It can't be right. Pass. Say what? Vector empty lang tokenize. Where's all the parse functions? Oh, I didn't put a pass at the end. Stupid. And it did pass. I know for sure. So let's do this. We're right at the end. I'm going to go clean up the output so we can actually see what the hell is happening right now. Go back into script.c. Comment out these two log functions. Uncomment these two. Go back to compilation. GR. And parse list actually works now. So I think that that is a validation, at least that the conversion to vector for the parser has worked. It's a little bit flaky, and I don't know how it's going to work with even more nested vectors, but it does seem to be working at least from the high level pass. Man, that was a whole ordeal. That was crazy. Let me check one more thing too. If I iterate on the outer cursor, so let's see, expert. First of all, I want to see what flux vector cursor has next says for the outer cursor for this. So assert equal. I want to see if it says 0, because in theory it shouldn't have a next item, the outer list. So this is going to be a cursor called list cursor, not sub list cursor. So we're going to go forward to sub, delete that. Okay, delete that line. We're going to run the test one more time. Okay, so it tells me that there's no next item, which is basically what I expect from the outer cursor as well, because this the sub list we're looking at is actually the circle call expression, and the outer list is the top level list of expressions. So if there was another expression after this, let's just do this and see what happens. 15. Then that last one should fail because at the end, there's still one expression left. So if I delete that again, oh, segmentation fault now. That's funny. Why did that happen? Oh, no, that's because of the eval function's not working. So the eval test functions are broken right now because I need to go fix the rest of that. I'll fix that another time. So let's try to commit this code. All right, so we broke the value kind into integer and string. We made new structs for those. We changed the signature of flux script parse. We changed this to assigned integer. We deleted some stuff here and replaced it with an actual calculation, which should be right. Strangely, this, let's see, C printf long. Is it, needs to be something else after that. Can you give me the link? LU. Well, I can't even read that right now anyway, so it's kind of a moot point. So, fix some calls here. Let's clean this up. That's not needed anymore. That's not needed anymore. Okay, and that looks better. This part also is... Wait, that's the old code. Yeah. All that looks good. That looks good. Everything there looks like what I would like to check in. That part needs to go. This part can go. And some of this stuff here needs to change, but that's going to come later. And we're looking at all the test code just to see what we can commit. All right. We're going to stage that. Vector C, yeah. That changed. Oh, this is the test code. Okay, yeah. All right, here we go. I think that's good enough. Okay. Convert parser, or let's see, refactor parser to use the Flux Vector API with great pain and suffering. Let's just put that down here. Okay, so I'm going to push that code, and we're going to put a link to that in the show notes in case you want to take a look at it, which probably you don't because you've seen enough of it by now if you're watching up until the end here. Let me see. Go to Flux Compose. Just going to copy the link for that. Aeatus. And I'm going to go to the scripting branch and pull that commit just to get the link to that. Go back in here. So next steps. So as we discussed, next time we'll take a break from the scripting side of things and talk about converting the app to use GLFW and raw OpenGL instead of SDL2. So we're not going to put to-do list items there. And we did this. We finished porting parser to Vector API. I mean, geez, that was just 3 hours of hell, honestly. Thank you all who stuck around and watched that. And we didn't get to any of the other stuff, but we will get back to those things in the future, actually. So I'll go ahead and commit these as well. So and Arnav asks, am I thinking of making more systems programming videos on the other channel? Yeah, I am thinking about doing some videos on systems programming on System Crafters, probably about C and maybe about some other systems programming related topics because I'm really interested in it. As you can see, I'm willing to put myself through this kind of suffering just to write some code in C. So we will definitely talk about that at some point in the future, for sure. Okay, well, that's enough for one day. I've got to go eat some food and then go to some meetings. So thank you all who stuck around and watched this journey into the difficulties of dealing with C whenever you're writing custom data structures. I appreciate you being here for that. If you are watching the recording of the stream and you've gotten to this point, definitely leave a note in the comments. Let me know, because I'm just curious to see how many people watch the recording all the way through. GK Pseudo says C system crafters. Yeah, we're going to be like that at some point. And yeah, we'll be back on Tuesday. Keep in mind that the time is going to be different next Tuesday. We're going to start 1 hour later than usual and only go for 2 hours instead of 3. We're going to start at, I guess it would be 3 o'clock UTC. So, or 3 p.m. UTC. So keep an eye out for that. And we will see you next time. There may or may not be a System Crafter stream tomorrow. I haven't decided yet. Keep an eye out for that if you watch System Crafters, which probably all of you here do, I guess. So anyway, thanks again, everybody, and we'll see you next time. Keep it creative. Also, I fixed the font on the screen, in case you were wondering.